Hello, this is Miss Moore, and we are going to continue our discussion of the gas law. Today we're going to talk about the combined gas law. So essential question, how do pressure, volume, and temperature of a gas interact to affect the behavior of a gas? All right, the combined gas law. The combined gas law uses all three variables, pressure, volume, and temperature, in predicting the behavior of a gas under various conditions. So today we're going to continue using our formula P1V1 over T1 equals P2V2 over D2. This is the last law, gas law, that uses this equation. So P1V1 over T1 equals P2V2 over T2 is used for Charles' law, Gay-Lussac's law, Boyle's law, and now the combined gas law. All right, today's lecture is going to be really easy. What we're going to do is two practice problems. If you think you can do this without my help, why don't you hit pause and try to do it, and then hit play and see how you did. All right, so we're going to be still using the same formula, P1V1 over T1 equals P2V2 over T2. And let's read through the problem and list out our variables. Let's go ahead and try highlighting the ones in yellow. We'll start with that. So we have a weather balloon containing helium with a volume of 410 liters. It rises in the atmosphere and is cooled from 27 degrees Celsius to negative 27 degrees Celsius. So I would say that's our original temperature, right? The pressure is reduced from 110 kPa to 25 kPa. What is the volume of the gas at the lower temperature and pressure? Okay, so our V1 is going to be that one, and now our 2s are going to be the negative 27 degrees Celsius, the 25 kPa, and the, what is the volume? All right, let's go ahead and fill this in. 410 is our V1, 27 degrees Celsius is our T1, and 110 kPa is our P1. All right, when we go to our 2s, we have 25 kPa as our P1. Our volume is X, and our T2, sorry, these are 2s. Our T2 is negative 27 degrees Celsius. Okay. So the first thing we have to do before we even plug this stuff in is figure out our temperatures in Kelvin, which remember you take your Celsius temperature and add 273 to get Kelvin. And I got 300 K for T1 and 246 K for T2. All right, so now let's block this stuff off. Now let's go ahead and plug this into our P1V1 over T1 equals P2V2 over T2. So we're going to have P1 times V1, over T1 equals P2 times V2 divided by T2. All right, and from here, I'm going to go ahead and make us a little space here. I'm going to get rid of that. The next thing we can do is cross multiply, giving us 110, write that a little neater, 110 kPa times 410 liters times 246 K equals 300 K times 25 kPa times x. All right, so let's go ahead and do our multiplication there. And when I multiplied the left side, I ended up with 11,094.6 kPa liters K. And for the right side, I got 7,500 K. I guess I need to put this down below. I got 7,500 K kPa x. All right, so now to get the x by itself, we're going to go ahead and divide by everybody next door to the x, which is 7,500 K kPa. So 7,500 K kPa. So our K's cross out and our kPa's cross out. And that gives us 1479.28 liters. So now we need to go back and look at sig figs. We have 2 and 2 and 3 and 3. So it'll be 2. So our final answer will be 1,500 liters. Not much different than doing Charles Boyle's or Guy Lussac. The only difference is just a few more numbers to poke in. Okay, let's try one more. This time, whether or not you hit pause before, hit pause, try to do this by yourself. Let's start by figuring out who our P1, V1, T1s and P2, V2, T2s are. So when we read through the story, it says a sample of methane gas that initially occupies 800 milliliters at STP is compressed to a volume of 700 milliliters. To what temperature will the gas need to be changed to change the pressure of the gas to 12 atm? All right, so they tell us that initially the gas occupies 850 milliliters at STP. So those are our ones. The volume is then compressed to 700 milliliters. What temperatures are X, and to change the pressure of the gas to 12 atm. All right, so now let's fill these guys in. Our pressure 1 is standard pressure, which is 1 atm. Our volume 1 is 850 milliliters, and our temperature 1 is standard temperature, which is 0 degrees Celsius or 273 K. All right, our pressure 2 is 12.0 atm. Our volume 2 is 700 milliliters, and our temperature 2 is our X. So now we're just going to take that information and put it in our formula. P1 V1 over T1 equals P2 V2 over T2. So we have got 1 atm times 850 milliliters over 273 K equals our P2, which is 12 atm. Get rid of this here, it's kind of in our way. Times 700 milliliters divided by X. Now we'll cross multiply, giving us 1 atm times 850 milliliters times X equals 273 K times 12 atm times 700 milliliters. All right, let's stick this in our calculator and see what kind of numbers we come up with. All right, the right side's not too bad, right? We end up with 850 ATM milliliters X equals 2293200 K ATM milliliters. All right, so now we need to get the X by itself. So we'll be dividing by 850 ATM milliliters. So milliliters crosses out, ATM crosses out. And when we stick that in our calculators, we get, let's see, 2697.88, etc., K. So let's see. We got to look at sig figs. We have, he's a given, so you don't worry about him. We have 2 and 3 and 3 and 3. So 2 sig figs. And I'm kind of out of room here, so I'll put my final answer over here. So it looks like we're going to have 2700 K. Alrighty, that's it for today. Have a good one.